So trigonometry is a branch of math that deals with relationships between the side lengths and angles of triangles. So before we can actually use trigonometric functions, we need to be able to understand how to identify the opposite leg, adjacent leg, and hypotenuse with respect to an acute angle of a triangle. So let's take a look at this green right triangle right here. So we see that the right angle is where the box is, and this Greek symbol theta represents the measure of an acute angle in degrees. So by acute, I mean an angle that measures more than 0 degrees, less than 90 degrees. So this could be any acute angle measure. It could be 42 degrees, it could be 63 degrees, as long as it's between 0 degrees and 90 degrees. Now, with respect to theta, we can identify which leg is the opposite leg and which leg is the adjacent leg. So the legs are always the two sides of the right triangle that form the right angle. So the leg that's on the same side as the given acute angle and the right angle is called the adjacent leg. So I'm just going to put an A for adjacent. And then the other leg is going to be the opposite leg. Why? Because it's opposite the theta. Now, the side of any right triangle that's opposite the right angle, meaning it's the only side that doesn't touch this box. You see how these two sides touch the box? Well, the only side of the right triangle that is not touching that box is called the hypotenuse. And the hypotenuse is always the longest side of any right triangle. So I'm going to put an H here for hypotenuse. So now we're going to work with this yellow right triangle, and you'll notice that it's oriented differently than the last triangle we were looking at. Now, instead of giving you a theta symbol, I've actually given you the measure of theta, which is 60 degrees. And we're going to figure out which side is opposite leg, adjacent leg, and the hypotenuse with respect to this 60-degree angle. Now, remember that the hypotenuse is always the side of the right triangle that's opposite of the right angle. So which side is the only side that does not touch this right angle? This one. So I'm going to label this as H for hypotenuse. Now, remember that the legs are the two sides that form the right angle. One of the legs is the adjacent leg and the other leg is the opposite leg. So the adjacent leg is on the same side as the given acute angle and the right angle. So that would make this the adjacent leg. And then, of course, the only other leg, this one right here, is going to be the opposite leg. So now that we understand how to identify the hypotenuse, opposite leg, and adjacent leg with respect to an acute angle of a right triangle, we're ready to learn about the three trig functions that we can use to solve for a missing side length of a right triangle. Now, to be able to use these three functions, we need an angle of a right triangle other than the right angle, and we also need at least one side length of that right triangle. Now, the three trig functions are the sine function, the cosine function, and the tan function. Now, the three formulas that I'm about to go over, you can memorize using the acronym SOHCAHTOA. And what that stands for is the SO part stands for the sine of an acute angle is equal to the opposite leg with respect to that angle over the hypotenuse. The CA part stands for the cosine of an angle, acute angle, is equal to the adjacent leg with respect to that acute angle over the hypotenuse. And finally, the TOA part stands for the tan of an acute angle is equal to the opposite leg with respect to that angle over the adjacent leg with respect to that angle. So as an example, suppose we have this right triangle with all side lengths given, and we want to figure out the sine of angle E. So what we're going to do is we're going to put our little theta symbol at angle E to show that that's the acute angle we're interested in. And to figure out the sine of angle E, we just need to know the formula for the sine function. And from SOHCAHTOA, we know that the sine of an angle is equal to the opposite leg over the hypotenuse. So what is the opposite leg in relation to theta? The 4. So the 4 goes on top. And then we ask ourselves, what is the hypotenuse of the triangle? And that's, of course, the 5, since 5 is the only side of this triangle that does not touch the box. So it's opposite the box. So the sine of angle E is going to be equal to 4 over 5. Okay, so now if we're asked to find the cosine of angle E, we look at our cosine function, and we know from SOHCAHTOA that the cosine of an angle is equal to the adjacent leg with respect to that angle over the hypotenuse. Now, the adjacent leg, remember, is on the same side as the marked acute angle and the right angle, so that's going to be the 3. And then we put that over the hypotenuse, and we learned from the last example that the hypotenuse of the right triangle was 5. So the cosine of angle E is equal to 3 over 5. Now, suppose I'm asked to find the tangent of angle G. Now, this time the angle that we're interested in has changed, so I'm going to put my theta at angle G instead. Now, based on our formula, the tangent of an angle is equal to the opposite leg with respect to that angle over the adjacent leg. So now we're going to ask ourselves, which leg is opposite to this angle? Well, that's the 3, so this time 3 is going to be the opposite. And which leg is the adjacent leg? Well, remember that the adjacent leg is on the same side as the marked acute angle and the right angle, so 4 is going to be the adjacent leg. So opposite over adjacent in this case is going to be equal to 3 over 4. So now it's time to go over a real-world example of how you actually use the trig functions. So suppose a 16-foot ladder is leaning against a wall. If the angle of elevation the ladder makes with the ground is 52 degrees, how high up the wall does the ladder reach? Now, you might be wondering what angle of elevation is. So in the case of a right triangle, it's the angle that the hypotenuse is going to make with the base. Or equivalently, the angle that the hypotenuse makes with the horizontal segment of the right triangle. So to start solving a problem like this, let's first identify what we've been given. So we've been given the 52 degrees as our acute angle, and we want to identify, have we been given the opposite and adjacent, opposite and hypotenuse, or adjacent and hypotenuse with respect to this angle. So what would the x be in relation to this angle? Well, that would be the opposite leg, since it's the leg that it does not touch this angle. It's the leg that's across from this angle. So we're just going to label the side that's labeled x as O for opposite. And then, of course, we know that the hypotenuse of a right triangle is always opposite the right angle. So that 16 feet is going to represent the hypotenuse. So I'm going to put an H there for hypotenuse. So the next thing we want to ask ourselves is, which function out of the sine, cosine, and tangent functions contains the opposite and the hypotenuse? Well, that's the sine function, because the sine of an angle is equal to the opposite leg over the hypotenuse. So that tells us right away how we're going to solve the problem. Okay, so we've established that we're going to use the sine function in order to solve for how high the ladder reaches on the wall. So the sine function, once again, tells us that the sine of an angle is equal to the opposite leg with respect to that angle over the hypotenuse. So the theta in this case is our 52-degree angle, so the acute angle. So we're just going to plug in 52 for theta. We've established that the opposite leg in relation to the 52-degree angle is x, so we plug that in for the opposite leg. And then the hypotenuse was 16. So now it's just a matter of solving the equation. The sine of 52 is equal to x over 16. So what we're going to do is the trig function, we're going to put over 1. And that allows us to do some cross multiplication to figure out the value of x. So now that we have this equation, let's cross multiply. So we have that 1 times x is equal to x. And then we're going to set that equal to what we get when we cross multiply in the other direction. So 16 times the sine of 52. For now, we're just going to leave it as 16 times the sine of 52, which is what that means when we put those two next to each other. Now, if you're using a TI-84 plus graphing calculator to do this, you want to make sure that it's in degree mode before you can actually calculate the sign of a value. You could do that by hitting the mode button, which is next to the second key, and just making sure that the third line is set to degree instead of radian, and then you can go back to the home screen by hitting second mode. Now, if you're using an iPhone calculator, you want to make sure that you're holding your iPhone calculator horizontally the long way. And what you can do is if you want to figure out what the sign of 52 is, just hit 52 and then the sign button, and that value should appear. And again, you want to make sure that your iPhone calculator is set to degree instead of radian. So it should actually say, the irony of this is that it should actually say rad for radian, like in the corner when it's set to degree mode. So when you do the sine of 52, that's actually equal to roughly 0.79. And then, so sine of 52 is 0.79, and then you can multiply that by 16. And when you do that, you get 12.6. So that tells us that the height of the ladder that the ladder reaches on the wall is going to be 12.6 feet. Okay, so just one more example. Now, suppose we're given this right triangle, and we can see that the acute angle we've been given is 60 degrees, and we want to solve for the value of x. So remember, the first thing we have to do is identify which sides we've been given in relation to the 60-degree angle. Now, the 12 feet is on the same side as the right angle and the acute angle, which means that that's going to be the adjacent leg. And then the x is opposite the right angle, so that would make that the hypotenuse. So what function do we use when we're given the adjacent leg and the hypotenuse? Well, that's the cosine function. So we're going to use the cosine function to solve for the value of x. So for theta, we're going to plug in 60 since we've been given the 60-degree angle. And the adjacent leg we've established is 12, so we're going to plug in 12 for the adjacent leg, and x is the hypotenuse. So you'll notice that this is different from the last problem we did because this time the variable is in the denominator of the fraction on the right-hand side of the equation. So at this point, what we're going to do is we're going to put the trig function, which is the cosine of 60, over 1, which allows us to do some cross multiplication to solve for the value of x. So when we cross multiply, so we do x times the cosine of 60, and we get x times the cosine of 60 down here, and then 1 times 12 gives us 12. So now it's a matter of solving this equation right here. Now, the cosine of 60 is just a constant, or just a single value. So what we're going to do is divide both sides by the cosine of 60 to get x by itself, because what's going to happen is that the cosine of 60 is going to cancel over here, isolating the x. And now x is equal to 12 divided by the cosine of 60. So when we do 12 divided by the cosine of 60, we should get 24. Now you can also calculate the cosine of 60 separately on your calculator. You're going to see that the cosine of 60 is equal to 1/2 or 0.5. 12 divided by 0.5 will give you 24 feet, which is going to be the value of x in our diagram.